Right, hi everyone. I'm from the Met Office, which is the UK's National Weather and Climate Bureau, and I'm here to talk to you about maps in Python. And so, first of all, a bit of a thank you to everyone involved. So this thing came from some backroom discussions with Phil Elson and myself, but since then we've acquired a whole slew of very valuable contributors. And in this particular presentation, I've cribbed an awful lot of material from something that a chap called Bill Little has done. That's I'll make another link to that at the end. He's put together some training material we use in-house for our scientists, and yeah, it's up on the web. Okay, so Cartopy, what is it? It is, in antagonistic terms, it's a replacement for Basemap, because Basemap couldn't do quite what we needed it to do. Put in perhaps a friendlier way, Matplotlib's moved forward quite a bit since Basemap was written, and so there's more things we can take advantage of, and you can make things more seamless. And now we've got more requirements. Obviously, you can take that into account when you're actually building the thing in the first place. Now, Cartopy span out of a project at the Met Office called IRIS, which is dealing with meteorological and oceanographic data. And there are some plotting requirements to do with rotated pole coordinate systems, which is where you take a lat-long coordinate system and you pretend the North Pole is somewhere else, that Basemap was having real problems with. So we thought, okay, well, how do we actually deal with this problem rather than keep sort of skirting around the issue? So getting started actually using Cartopy, it integrates with Matplotlib really quite nicely now. Phil Elson did an awful lot of good work on this to make sure that it's as painless as possible. And fundamentally, you interact with it in two ways. One, when you're setting up your axes to plot something, you tell it what kind of map you want to plot. And then secondly, when you're putting some data on that map, you say, what kind of coordinate system does my data come from? And then you don't have to worry about anything else. At least that's the plan. It doesn't always work, but we'll fix that. We've got some good plans for that. Hello World. Yeah, the great thing about drawing maps is you can actually do Hello World with a map. So you can see this in action. We've done a plat carry map. I haven't got an accent on the E, because this is not really, I need to fix that. Actually on the name of the class. Does anyone want accents on the names of classes? Not enough people using Python 3 yet, right, okay. So it just integrates some completely regular Matplotlib style. We're using the PyPlot interface here. We're putting titles onto the thing. We see there's a couple of extra methods there that are special, and that's because this isn't a normal axes class. It's a subclass of an axes. But I'll come back to those things in more detail in the future. So this projection keyword, this isn't ours. This is something that Matplotlib has anyway. You used to be able to do polar plots with this stuff. And we just generalized it so that you can now do slightly fruitier transformations. So it works with subplot, just in exactly the same way. There's no extra magic involved. And once you've got your map set up, you can then use all the standard Matplotlib commands to do things, because they already had a transform argument, and now it's just a question of we plumbed in all the kind of map projection stuff into that transform argument. So those of you that went to the WCS Axes talk an hour or so ago, the room next door, it's exactly the same technique that they're using there. They're making use of the transform keyword argument that already exists on Matplotlib commands. So we're going to build this up just starting from the simple things. If you want to plot some plot points in Matplotlib, you just do plot.plot. So that line there, any of you that plotted points in Matplotlib, that you won't find that at all surprising, except transform at the end, instead of being like transdata or transfig or whatever it is, we're putting in a map projection and saying, well, these coordinates are actually longitudes and latitudes describing a position on a sphere. And then Cartopy takes care of mapping that onto the actual map projection itself, which is Molvider, and pops in the right place. It's the same question with same with lines. You just do what you'd normally do in Matplotlib, but just magically it takes care of the projection. One thing that you'll notice is slightly different from if you did see the WCS axis projection stuff before, is that line is a curved line. That's because, well, sort of curved. That's because I've said this is a geodetic coordinate system, so therefore what we count as a straight line in a geodetic coordinate system is actually a great circle. To be honest, if I could have done a straight line in a stereographic projection or an orthographic, and again, that would have come out as some strange distorted line on the map. And Cartopy would take care of making sure that the curve is as smooth as it need be, except there it doesn't. But that's a ridiculous bug, that is. That's been in there since day one, and it's like a one-line fix. But anyway, that will get fixed. Building up to the next level, polygons. So again, you just do plot.fill, just like you normally would do. And it takes care of the fact that there do these strange tears, and you've gone around the back of the Earth and all that kind of stuff. It just does that for you. So you don't have to worry about it. It even takes care of if you've got a polygon that has turned itself inside out because you're doing an orthographic projection, say, or stereographic. And then this builds up within the standard things like contour F, p-color mesh, all the normal stuff just works. So again, if that had gone off to one side, then half of your mesh would then just appear on the left-hand side and it would all be fine. Again, quiver, just works as you'd expect. One thing you notice there, though, is you can see the fact that the data points are obviously spread out and the position, their relative positions on this map are different. The spacings are different. Sometimes that's not what you want. Sometimes you actually want, it makes it easier to visualize what's going on if you resample those things actually onto the map itself. So what we've got is there's an easy kind of way to hook into some helper functions that can do that kind of thing for you. So that's exactly the same data set, but now we've resampled it on the map's coordinate system, and it just makes it sometimes a little bit easier to see what's actually going on. And that actually then means you can do things like stream plot, because that relies on that kind of setup in the first place. Okay, images, yep. Again, bog standard matplotlib syntax. We're just doing imshow. This particular kind of image says, the origins in the top left-hand corner. That's pretty common. The extent, I'm not actually showing the extent there, but the extent is just a tuple, the regular kind of tuple that you get in matplotlib. So it's got 4 members, and those are then the extent in the coordinate system that you said that the data is in. So you don't have to worry about working out where it is on the map or anything like that. That's all taken care of for you. And again, that will work globally. So you can take an image of the North Pole, and then you can look at that from the Platt carry projection, and you'll get some sort of weird stripy thing across the top of your screen, but it's the right weird stripy thing. So that's all fine. And we do use those kind of facilities for labeling places and annotating stuff. But you also want to get access to real data, or common data sets. So we've provided a bunch of interfaces that let you just basically build on what's already there to access the kind of things you can see there. I'm not going to go through all of those. I'm just going to pick a couple of them. So we've already seen this one in action. So the coastline data comes from Natural Earth. And Natural Earth provide 3 different resolutions of coastlines and everything else they do, or pretty much everything else they do. 1 to 110 million for doing real big, just zoomed out maps. 1 to 50 million and 1 to 10 million. Now we default to 110, but you can change that. And there we go, instead of 1 to 10 million, which works really nicely for doing the UK, so well done them. There's often just bits missing, but anyway. The point being, when you do this, it will automatically go off and download the data you need from Natural Earth. We don't ship all the data with it, so you just get the latest data, and it'll cache it for you. So it makes it really easy to just make, you don't even think about this. It's just, I want to stick some coastlines on, fine, or I want to get some rivers or some lakes or some roads. It's a one-line job. And we do that using something called features, which is basically where we take a description of points and lines and all that kind of stuff, and we bundle it up with the coordinate system that they're described in, and the matplotlib styling keywords that you want to render it with. So we've got an example here saying, well, I want the 1 to 10 million roads from Natural Earth, and I want to draw them in red, etc. So the coastline command that we saw there is just like a a convenience function on a convenience function to just make it super easy to say, well, I want the natural Earth coastlines at 110 million or whatever. So if we dump all that into one, there's two pieces there. I'll do the second one first. So we've just seen that natural Earth definition. We're just saying we want roads in red, and we just add that to the axes. Wherever you are on the axes, it'll now just draw the relevant bits. It only projects the bit, well, it only plots the bits it needs to behind the scenes, so it's not too bad. And then we've got a whole bunch of these sort of pre-canned natural Earth features. So the lakes one there is rendering it in blue because we've just, that's sensible usually when you're drawing lakes. And so, yeah, the coastline is just another one of those. So there's sort of layers of convenience there, depending on how much you want to unpack and get in there. Okay, I'm curious here, actually. Can I have a show of hands? Who actually uses OGC web services in their day-to-day work? Okay, that's actually slightly more than I thought it would be. I thought it might be one, but... So for those of you who don't know, the Open Geospatial Consortium, they've defined a series of web APIs for describing geospatial data in various different forms. And there are a couple of them that are to do with raster data. So you've got web map services and you've got web map tiling services, which we've integrated into Cartopy. Now these things, you have a URL that describes like a service endpoint, and then you can query that URL to get a list of what services are provided and what extents they cover and all this kind of stuff. And a given service can provide as many layers as you want, so you can, 20, 30 different raster layers from one service. That's not a problem at all. And you can just choose which one you want, and then it'll hand you back the data. So WMS is for making like regional requests. You just give a sort of a bounding box, and it'll give you back an image that covers that bounding box. And WMTS is like a kind of a slightly generalized version of the sort of Google map tile that you've all probably seen. And it just lets you, have different coordinate systems and tiles that are only enough to find over a small region of the Earth, all this kind of stuff. So, as you can see, to integrate that into Cartopy, all you have to do is give it the name of one of these endpoints and the name of the layer that you want to put in. Cartopy will then select the appropriate sort of zoom level, choose the tiles, download them, cache them, stick them on your image, and it's as simple as that. So now comes the time for the live demo. So we can see actually there's the list of layers that are exposed by the server. There's quite a few there. So I've gone for the one that looks, let's see if we make that a bit bigger. So because I've made that a bit bigger, I think it's changed zoom level, so it's downloaded a few more tiles. And I'm going to try, let's see if we can see ourselves. Now I know we don't live there. There's a reason, which you probably tweaked already. Go on. Depends on the speed of the Wi-Fi, obviously. So as you can see, as you're zooming in, it's downloading fresh tiles, getting more detail. And if we're really lucky, I'm going to switch. Here we go. It'll be quicker.
It's the Cartopy figure. The Cartopy figure that you're zooming.
Oh, so this is pretty much the code you just saw, right? So it's just this, right? But without it's a slightly different layer name. It's just the real color layer name, and I've just made it global rather than zoomed in. So it literally is just that. I can show you the source code. But it's cloudy in the Middle East. Who knew? Somewhere about there, I think there's that kind of map of the world that's made out of sand. But anyway, there we go. So it's kind of fun, which is one reason for doing it. But just shows you the fact that you don't have to worry about the resolutions. Okay, this thing will just choose the right tiles for you. Okay, go on, go away. Right. So, actually, I've got plenty of time, haven't I? Oh, 5 minutes. Okay, fair enough. That is plenty of time. I could maybe have told you about some of the other things, but we can do that in questions. Where's it going next? Well, there are still some quirks in the generality of being able to do data from any projection onto any other projection. We know that. We've got some plans that we've been hatching as to how to fix that, which might simultaneously take care of some of the performance issues as well. That'd be nice. We know we need better grid lines, and we've seen people do better grid lines in an earlier presentation, so that's great. Hopefully we can hook up and get something good out of that. There are obviously some minor things we're planning on doing as well, but also if you are using Cartopy or would like to use Cartopy, do tell us if there's something that's missing, because we'd love to put it in there. Now, I promised to mention Bill's thing again. I guess we're going to share these slides on the website afterwards.
I think just on GitHub. I don't know if
Okay. All right. So, where are these things? So under the SciTools organization on GitHub, we've got some courses, and there's loads of good stuff there, including some of the background material for this kind of thing. So feel free to go along and crib that. Yeah, thank you.